Hello, everyone. Today we are going to talk about what information we can extract from a graph of a function. So I'm going to start with drawing a graph, and we're going to talk like what we can see from this graph. The graph of a function I'm going to draw is graph of f of x equals a square root of 4 minus x squared. Well, you don't need to worry about graphing it. I'm going to do it for you. Imagine that either graphing calculator did this or I did. Right now, we'll need to kind of just look at the graph, not like this blue color. So the graph of this function is going to look like a half circle. And doesn't look very nice. Okay, but still, that's -2, that's 2. Another 2. Imagine somebody just gives you the graph. What kind of information we can get from this graph? Well, first we can talk about domain and range of this function. What is domain? Domain are possible axes, right? So let's write down domain. What is domain over here? Well, x changes from -2 to 2. So I'm going to say that this is domain. X belongs to the interval from -2 to 2. I include both -2 and 2. If you plug them into the function or look at the graph, you're going to see that they both are included. Now, what is range? Range is all possible y's, right? If you look at y-axis, we see that y changes from 0, and y equals 0 at this point and at this point, and goes up to 2. So I'm going to color in green the y. And then I'm going to write down the range. Oh, sorry. Let me erase it actually. I don't want to have double range here. So range. And the range is interval of possible y's. And in our case, it's going to be from 0 to 2. And you see that they are not equal and they don't go to infinity. Well, happens sometimes. Now, last class, we learned about increasing and decreasing function. We remember that if something goes up, it's increasing. If something goes down, it's decreasing. And of course, for the very same function, different directions of moving is going to give you different intervals of increase and decrease. We remember that whoever is moving up or down is supposed to walk in a positive direction of x-axis. So somebody walks from the left to the right. Now let's look at our graph. So what do we see over here? Well, if we walk from -2 towards 0, I mean axis, we're going to climb up, right? And I'm going to show up. So I'm going to write down increasing. The function is increasing on interval from -2 to 0. Usually we don't include endpoints of the interval because increase does not happen at the point. Increase happens on interval or between 2 points, not like at certain point. Okay, now after 0, after we pass 0, again, we are walking like kind of on x-axis. We are going to go down, right? Down means that, well, my down doesn't look very good, okay, but the function is decreasing. Decreasing means that it's going to happen between 0 and 2, right? X belongs to the interval between 0 and 2. Well, now I'm going to ask you to investigate a function and find out the very same stuff for the function. Domain, range, increasing and decreasing. Okay, I'm going to give you a very, very simple function. And the function is going to be, just for self-work, the function is going to be x squared plus 2. Okay, I want you to find the domain of this function, range of this function, increasing and decreasing. And I want you to graph it first. I think that's going to help us a lot to kind of identify all this stuff. And as usual, you can stop my video, do the graph and see how the graph looks and write down all the intervals. Probably need 5 minutes. And then turn the video back and watch how I solve it. I'm not going to do this. I'm just going to count to 5 and give you solution. Okay, so 1, 2, 3, 4, 5. Okay, guys, what we have? We have a parabola and plus 2. For now, because you don't know about transformations yet, you can just do the table. I'm going to do the table over here for this graph. I'm going to put x here and y over here. You can put f of x also. I'm going to do just 3 points. I'm going to do x equals -1, 0, and 1. So at -1, 1 squared is going to be 1, plus 2 is 3. At 0, it's going to be 2. And at 1, it's again going to be 3. Well, I know that parabola looks like kind of a bow, right? So I'm not going to graph too many points. I just need to see how it looks basically. Okay, well, I think I should graph my x-axis lower, maybe over here. Need to give myself more space here. Okay, let's start graphing. If we imagine that 1 is here and 1 is here and there is 0. So at -1, the function equals 3. Okay, so that's somewhere here, 3, right? At 0 equals 2, and at 1 equals 3. Now, if I do the graph is going to look like this. No, typical parabola, right? Okay, now on this graph, let's first state what is domain. Domain. Well, for domain, we'll need to check which axis we can plug into the function. It looks like we can have all possible axes here, right? So I'm going to write down that domain is x belongs from -infinity to +infinity, all number line. Range. Range are possible y's. Let me go to green color and color y's which are possible. You see that y's do not start at 0. They start actually at 2. And then they go to infinity. I'm going to write down a range. I think letter N. Range y belongs and from 2 to infinity. Why do I include 2? Well, at 2 actual function equals 2, right? Function gets this value. Now, if we want an interval of increase, what do we have? Well, increasing going up is over here from 0 and like in this direction, right? Going up. So I'm going to write down the function is increasing from 0 to infinity. Again, we are labeling interval as x. So function, yeah, actually increase happens in y, but y is kind of altitude and x is a coordinate. So we want to know like between which coordinates we are climbing up. Okay, decreasing. Well, for decreasing, we go down over here, right? From -infinity to 0. So I'm going to write down from -infinity to 0. And yes, we did answer all the questions. Now, guys, one more piece of information we can get from the graph is called a local and global maximum and minimum values. I'll need to first explain what they are and then kind of ask you to do a problem. Global and local maximum and minimum values. Well, first, I want to say a couple of words about definition. What is like maximum and what is minimum? Well, you kind of understand from the word that maximum is something which is like the highest, right? For example, if you talk about the Earth, on the Earth, we have the highest point, and the highest point on the Earth is Mount Everest. So we're going to call it a global maximum. I'm going to write Mount Everest. That's just the highest point on the Earth, right? Well, besides some very great mountains on the Earth, like Mount Everest, we have some kind of lower mountains, right? And they are called local maxima. Local maxima are just like maximum in a certain region. For example, what is kind of a tall mountain here? Nearby me, Mount Wilson, I think. So I'm going to write down local Local maximum, Mount Wilson. Just a maximum somewhere around, like in a certain region. For minimum, well, guys, do you remember what is actually the lowest point on Earth? If you kind of recall maybe some geography, you are going to remember that the lowest point is Mariana Trench. And Mariana Trench is even lower than Mount Everest high. Mount Everest is high as 8,849 meters. And global minimum Mariana Trench is 11,034 meters. Well, that's how deep it goes. And that's a global minimum because there is no deeper point on Earth. But we do have local minima. Local minima are like something which is deep, but not as deep as Mariana Trench. What can it be? Well, I don't know. For example, Death Valley or Grand Canyon also goes deep, but not as deep. Well, I'm going to write down Grand Canyon, okay? Grand Canyon. I don't remember how deep it goes, and so I don't remember how tall is Mount Wilson, but you understand that they kind of the deepest point somewhere, but not exactly like all around the world. For functions, we can have the same situation. Just imagine that now function is a whole Earth, and it's going to have local and global maxima and minima. First, I'm going to go back and look at the functions we already have, and let's see what do we have there. I'm going to use highlighter and highlight something. So let's look at the first function. What do we have? What is my global maximum here? Well, global maximum, the tallest point or the highest point of the function is here, right? I'm going to label it as GM global maximum, right? Do we have a local maximum? Well, we can also say that it's local maximum just because there is no other maxima around. And global maximum is, of course, maximum in some region too. So if you choose a smaller region over here, it's still going to be the maximum. So it's a global maximum and a local maximum at the same time. How about these 2 points? These 2 points are the smallest point, right? And they are working as global minimum. Well, I should write down maximum over here. And I don't think that was a good idea to write down in yellow, actually. I should go back to black. Well, global minimum are the lowest points. What is interesting, guys, for local minimum, these 2 points are not going to work. Why? Well, because we don't know what happens to the function over here. If it was mountain, for example, you take a picture. These local minima points are end of the picture, and we don't know, like, maybe the mountain goes down, 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 or maybe the mountain actually goes up after this point. If it goes up after this point, that's going to be a local minimum and the global minimum at the same time. If it continues going down, then it's just a point, which is end of the picture. For right now, we're not going to be very concerned about like how to distinguish them. I'm going to give you questions where everything is going to be clear. But for just more clear understanding, for local maximum, your function must look like a hill, something like this. That's going to be local maximum. For a local minimum, your function must look like a dip, looking like this. End of the picture is not going to work, neither as local maximum or local minimum. They can work as the greatest point on the picture or the smallest point of the picture, but they're not going to look like local minimum or maximum. Okay. Well, it's impossible for Earth, but because if you take a picture of the whole Earth, you are not going to have an end of the picture like, but for function it happens sometimes, right? I'm going to draw just a fake function where I'm going to label local and global minima and maximum. Okay, so example, that's going to be just a graph of a function, and I'm drawing this graph to just show you something. Imagine that graph looks like this. And yes, the picture does not have actually like more continuation. It just ends at this point and ends at this point. So what we have on this picture, why don't I use a green color, but I make it a little bit thicker. So on this picture, we are going to have some local maxima, right? This, and this, they are tops, local maxima. We also have some local minima, right? Local minima, this and this. What else do we have? Well, guys, what is the highest point here on the picture, on the whole picture? This one. This is the global maximum. What is the lowest point on the picture? This one. This is global minimum. You see here, because it's end of the picture, it's not going to work as local minimum. End of the picture does not work. Only points like this are working as local minima. Okay, so these are local minima and this is not. But all 3 points are maxima. Okay, now guys, I'm going to ask you to do a couple of problems on your own. Let me scroll it up. And again, the same condition. I'm going to solve them, but I want you to try them on your own, okay? Self. Problem 1. F of x equals 3 minus x squared. And x here does not go from negative infinity to positive infinity. It goes from negative 3 to positive 3. I want you to graph it. Sorry, graph. Find the mean and range. And the intervals of increase and decrease. Increase, decrease. Question 2. Question 2, I'm going to give you a graph and I'll ask you to find actually intervals on this graph. This graph is going to have numbers. So I'm going to start over here. Sorry, I did not end at the graph where it's supposed to end. Let me redo this whole thing. One more time. Maybe I should use a small, thinner line. X-axis, x-axis, and it's -1. This is -1. This is 1, 2, 3, 2, and this is 3. That's x and that's y. Okay. Problem 3, I'm going to put it right over here. For problem 3, I want you to use the same graph as problem 2 and find a local minimum and maximum. Here in problem 2, I want the mean, no, I want increase and decrease interval. Same graph. Local maximum, minimum. Okay. Well, if you kind of can find global maximum, minimum also, very good. Okay, let's have like maybe 5 minutes so you can stop my video, and in 5 minutes, please come back and I'm going to count to 5. So 1, 2, 3, 4, 5. Okay, so I'm going to start with problem 1. Solving problem 1. So again, I'm going to use a table to graph my parabola in problem 1. X over here, y over here. Again, I'm going to start -1, 0, and 1. Maybe I did draw the line for too far. So at -1, it's going to be -1 squared is 1, 3 minus 1 is 2. At 0 is 3, and at 1 is going to be again 3 minus 1, 2. And I'm going to do the graph over here. I'll need 3 units at least. All right, okay. So what I have, at -1 is 2, then 3, and then 2 again. That's 1, that's 1, that's x, that's y, and that's how my graph is going to look. Yay. So that's just a parabola, right? So here the question was find the intervals of increase and decrease. Well, obviously we see that we go up over here, right? So increase is going to happen from negative infinity to 0. And then after 0, we go down, decrease from 0 to positive infinity. Well, that's basically all I'm asking in this question. For question 2, I'm going to look at the graph and kind of write down intervals right on the graph. So what we see, the function, we go down from -1 to 0. So I'm going to write down decrease from, oh, sorry, I was trying to write down parentheses, -1 to 0. Do we go down somewhere else? Yeah, guys, over here, we go down over here too. And that's from 2 to 3. I'm going to put U and then 2 to 3. That's decrease. Increase. Well, we are increasing from here, right? From 0 over here to 2. I'm going to write down 0 and 2. Okay, good. Now we want to do local minima and maxima. So what are local minima and maxima? Well, I see that the function has a smallest point over here, right? So you can write down that local minimum f of 0 and it equals -1. And local maximum, let's look at the picture, what we have. The local maximum is over here, right? You can write down f of 2 and equals to 3. Do we have a global minima or maxima? Actually, if you look at the picture, this local minima and maxima are also smallest and the highest points. So, and they are global too. So both are global. Both minima and maxima are global because they're highest and lowest points. Okay, so I'm going to write down minimum here and maximum here. Okay, that's all for this lecture and thank you for your attention.